So finally we got the very interesting differential equation which is here, and just if we can integrate both sides we can able to find the time for the constant power region. So let's go ahead and then integrate it. So I just put the integration both side and also put the limit at t1 the velocity, let's assume v1, and at t2 let's assume the velocity v2. And I went ahead and I draw the curve between this function and the velocity or speed of the vehicle. So this is y-axis, nothing but f of v. What is f of v? Is v divided by c minus dv minus a into vq. So why I am doing this? Because I wish there could have been a formula for this type of integration, but unfortunately there is no formula and we have to rely on our best friend, which is the first principle method of integration, which is nothing but the area under the curve. And if we take the step size so fine, then that value will be almost accurate, near to 99% of it, and hence we are going to integrate this by using some sort of approximation. So what is that approximation? Here we are going to do area under the curve. So let's assume I am going to integrate from speed, which is vehicle speed 4 meter per second to 10 meter per second, and the step size here I have taken 2, 4 to 6, 6 to 8, and 8 to 10. Now if we see here, this is nothing but a trapezoidal. So we know the formula of trapezoidal. What is the area of trapezoidal? Which is nothing but h1 plus h2 divided by 2 into L. What is L? Is nothing but the step size, this L. What is h1? Is the f of, let's say in this case f of 4. What is h2? Is f of 6. So next what I have taken, n is equal to 3, the number of steps 3, and then the step size in this case, which is nothing but 2. And then the next thing what we are going to do is just I'm going to calculate the area of all this 3 region. So come here, and then what I did, I wrote the area of this region here, which is f of 4 plus f of 6 divided by 2 multiplied by L. L here is going to be the 2, because I have taken the step size as a 2. Next I wrote the formula for this region, which is f of 6 plus f of 8 divided by 2 into L, and the next I have wrote the formula for this region, which is f of 8 plus f of 10 divided by 2 multiplied by L. In the next step what I did, I took the common L by 2 multiplied by the first value, which is f of 4 plus 2 into summation of all the intermediate step from f of 6 and f of 8, and then lastly we have f of 10. So we can write this in a general form. Let's say instead of n is equal to 3, I took n equal to 100 for more accuracy. Then we can write this in a more general case, which is total time is equal to L by 2 multiplied by the first value, which is f of v1 plus 2 into summation of all the intermediate steps plus the last value. And if we calculate this way, we will able to get the net time which is required to go from v1 to v2 in the constant power region, and we are going to utilize this formula for calculating the time. Now let's go back to the Excel sheet.